So the next section is on the rate of change. Now, rate of change may sound scary, but it's actually just slope. It uses a few different things in notation. The first one being it uses the Greek letter delta, which is a triangle. And all delta means is a shorthand way of saying the change in. So m, we know, is our slope, and it's a change in your y's over your change in your x. So we can rewrite it as m is now your change in y all over the change in x, which we also now know is y2 minus y1, the change in your y's, all over your two x values. And again, keeping your y2 and x2 as your first term. And again, you can choose either your 2 points as your starting point. Now, rates of change, of course, we talk about them all the time. We just don't necessarily say it's a rate of change. For instance, speed is kilometers per hour. So it's kilometers, there's your change in your y values, versus time, which is your change in your x values. So if you were to look at a graph of this, you would have your kilometers here and your time in hours here. Okay? And if we look at our wages, we make so many dollars per hour. So after so many hours, how much will you make? Same idea. Our dollars is going to be our salary, and our time, again in this case hours, will be your x value. So if we consider that these are going to involve a few word problems, let's take a look at number 9 in your book. It says a long distance runner passes the 24-kilometer mark of the race at 1 hour and 20 minutes and passes the 42-kilometer mark after 1 hour, so at 2 hours and 20 minutes. And assuming a constant rate, find the speed of the long distance runner in kilometers per hour. So here we want to have speed. That is our rate of change, and in terms of kilometers per hour. So our y values, our change in our y's, are kilometers, and the hours is going to be our x values. So again, we can look at this in terms of hours and kilometers, and if it helps you to do a visual, by all means. So it says at 1 hour and 20 minutes, so let's say 1 hour 20 minutes. Now 20 minutes is 20 out of 60, so it's going to be 1/3 of an hour. So it's going to be 1.3 repeating hours, technically. And then it says we're going to pass the 24 mark. So we would have a point here at 1 hour 20 minutes, and we would just be passing the 24-kilometer mark of the race. And they say the 42-kilometer point happens an hour later. So we're looking at 2 hours and 20 minutes. And we would have a point here. It says it's a constant rate, which means that it's not going to do anything like this in between. It's going to be constant, which means that you're going to have a straight line in between. So there's our graph so far. Now what we have to do is find the speed of the long distance runner in kilometers per hour. Well, the speed is the rate of change, which is your slope. So if we look at our slope formula, change in your y's all over your change in your x values, we can now use these points here, 1 hour 20 and 24, and here 2 hours and 20 minutes at 42. So your change in your y's are going to be 42 minus 24, assuming that I'm calling this one my y2 and this one here my y1. And I'd have 2.3 repeating, subtract 1.3 repeating, which is nice because the decimals will disappear. So we can then simplify this as follows. So 42 minus your 24 will give you then 18, and this will be your kilometers, all over 2.3 repeating minus 1.3 repeating will give you 1 hour. So in 1 hour they have gone 18 kilometers, and that's your rate of change. So your m is 18 kilometers per hour.